Today I'm answering the 1P IGCSE Edexcel paper from May 2018. Starting with question 1. Diagram 1 shows the orbits of two objects. Select words from the box to add the three missing labels to diagram 1. Now, first of all, this object here, which is what both objects are orbiting, that must be a star or our sun. We don't know which galaxy this belongs to, but it has to be a star. And remember that comets have extremely elliptical orbits. And elliptical means this orbit here, the really squashed oval, which is why this is a comet. And then the one with a more circular orbit is the planet. Diagram 2 shows the moon orbiting the Earth. Draw an arrow on diagram 2 to show the gravitational force acting on the moon due to the Earth. And you want an arrow that goes from the moon to the Earth because it's being attracted to the Earth. Give a name for a large collection of billions of stars. The definition is that of a galaxy, so that's why the answer here is galaxy, although you could have got away with saying universe. 2. The photograph shows a child bouncing on a trampoline. The box lists some types of energy: chemical, elastic, gravitational, kinetic, and thermal. The passage describes the process of bouncing on the trampoline. Use words from the box to complete the passage. Each word may be used once, more than once, or not at all. As the child falls, his something energy is mostly transferred to something energy. The key word here is falls. That therefore means by definition that he was at height, and that means he has gravitational energy, because that's the type of energy you gain at height. However, as he falls, it means that he's moving more, and that's why he's gained kinetic energy in the second step. When the child hits the trampoline, his something energy is transferred to. So we just want to copy down the energy we've just described. And here you could say, because remember trampoline is elasticated, you can use the word elastic to describe it, or you could have used thermal. Trampolines have springs that stretch and compress. A student investigates a spring to see if it obeys Hooke's law. She measures the extension of a spring for a range of different stretching forces. Describe how the student could measure the extension of the spring. So we just need to give a simple method here for helping the student to measure the extension of the spring. So clearly the student needs to measure the initial length of the spring. And what's the best way of doing this? Well, it's using a meter ruler. Then the student should measure the extended length . And lastly, you could say, we've already given 3 marks worth of thing, but you could also mention that you should take the measurements from the same points on the spring each time, or you should place the ruler with a 0 at the bottom of the spring. But for me, those aren't as obvious. 2. The student finds that the spring does obey Hooke's law. Sketch a graph of her results on the axis. So Hooke's law is all about how when you add loads to a spring and it starts extending, that the amount of load, so the amount of force, is proportional to the spring's extension. So based on the fact that it's directly proportional, you want use your ruler here, a straight line starting from the origin, something that looks like this. 3. The photograph shows an electrical appliance called a toaster. The toaster has a power of 1,800 watts when operating at a voltage of 230 volts. State the equation linking power, current, and voltage. So just out the way here, I'm going to use my formula triangle, which is PIV. So therefore, power is current, which is I, times voltage, and obviously you can write those out in full if you prefer. Show that the current in the toaster is about 8 amps. So let's write the correct variation of this formula. So current is power divided by voltage. We have a power of 1,800 watts divided by a voltage of 230 volts. When you pop that into your calculator, you'll get 7.83 amps, which is approximately 8. So you know you've got your answer right. Which fuse rating would be suitable for the toaster? So in order to work that out, we need to look at the current we've just calculated and pick a rating that is just above it. 1, 3 and 7 amps. So A, B, C options are all beneath it, which is why we have to go for D, 13 amps. The toaster uses mains electricity. Mains electricity provides alternating current. Describe the difference between alternating current and direct current. And this is something you need to just learn off by heart, these perfect definitions, which obviously my revision guides are full of. So an alternating current continuously changes direction. And you need all these words to get the marks. Whereas a direct current flows in one direction only. So really, I've just given two definitions there. State a source of direct current, well, you need to state here either a battery or a cell. If the question had said state a source of alternating current, you would have wanted to say mains electricity. 4. A student has a small piece of steel. Describe an experiment that he could use to find the density of steel. You may draw a diagram to help your answer. Well, we know I can't draw, so I will avoid drawing a diagram at any cost. But we're after the density of steel. So how do we work that out? Using this formula triangle, dmv. So we know that density is therefore calculated by doing mass divided by volume. So therefore, we need to work out both the mass of the steel and its volume. So calculate the mass of the steel using a measuring balance. Calculate the volume of the steel using, and remember, when you have an irregular shape, you use the water displacement method. So you have a beaker or a measuring cylinder would probably be better. You look at the original volume, you add your object, you look at the new volume. When you subtract the old volume from the new volume, you'll have the exact volume of the object. So I'm just going to say using the displacement method, or something like the Eureka can would be fine. And then lastly, calculate density by doing mass. So it's always good in physics to state appropriate equations. And then you could also talk about various experimental precautions. So reading from the meniscus when we're looking at displacement. Repeat and calculate an average. I love writing. There always tends to be marks for that. And that's all to do with reliability. And that is more than enough for 5 marks. 5. A student investigates how the length of a piece of wire affects its resistance. The photograph shows how he uses a ruler to measure the length of the wire. State how the student could improve the precision of his measurement. So precision is all to do with the increments on your measuring apparatus. So let's talk about the fact that the student could use a millimetre scale, because here we've only really got centimetres. Suggest 3 ways the student could improve the accuracy of his measurement. And accuracy is all to do with how correct an answer is. Now we can see from how the wire has been arranged, it's incredibly bent. So that's not going to give an accurate representation of its length at all. So first of all, we want to straighten the wire. Secondly, it seems to be hovering quite far away from the ruler, so we want to bring the wire closer to the ruler. And lastly, but very similarly, you want to make sure that the wire is parallel to the ruler. B. The student finds the resistance for 7 lengths of wire. He does this by passing a small current through each wire. Explain why the current in each wire must be small. And that's because when you increase the current within an object, you actually increase the heating of that object. So it actually gets hot, and that has a knock-on effect by altering the resistance. So you want to say, because high currents cause heating or cause a heating effect which would alter the resistance. The table shows the student's results, suggests 2 improvements the student can make to the data he collects. So let's have a look, and we can see we've got various lengths of wire, 10 centimetres, 15, 20, and then for some random reason it jumps to 50, 55, 60, 65. So that's pretty dodgy, so you want to say that you want to fill in the gap in results. So do extra wire lengths, e.g. 25, 30, 35, 40, 45, and you could also extend the range of lengths. So that could be above 65 centimetres. 3. Plot a graph of the student's results on the grid. Draw the line of best fit. So we're going to have resistance, because that's the dependent variable, the thing that we're measuring, on the y-axis, and make sure you remember your units. We want a length of wire on the x-axis, and the units here are centimetres, and then pick an appropriate scale that takes up as much of that graph paper as possible. So let's plot 10 centimetres versus 2.8 ohms. 15 centimetres is 4.5, and I'm not going to take all day to do this. I'm going to approximate where I'm drawing these because it's impossible to draw it accurately on the iPad anyway, but it should look something like this. And our line of best fit goes to as many of those points as possible. So we need to describe the relationship shown by the graph, and you can see that there is a linear relationship and that it is directly proportional, because as one value increases, the length of the wire increases, we see that the resistance increases. My favourite topic. This question is about parts of the electromagnetic spectrum. Which of these parts has the longest wavelength? So remember, there's that amazing song on YouTube where the guy sings and he goes radio waves, microwaves, infrared radiation, visible light, ultraviolet, X-rays, gamma rays. So we know that gamma has the shortest wavelength, so we need to move to the opposite end of the spectrum to find the longest wavelength, and that therefore is radio waves. State 2 properties that are the same for all parts of the electromagnetic spectrum. So remember, again on my guide, I say that EM waves all transfer energy. They're all transverse waves, and they all travel at the same speed in a vacuum. It's really worth learning these answers off by heart. So just pick any of those options here for the 2 properties. Discuss a use and a harmful effect for 3 parts of the electromagnetic spectrum. Notice that this is worth 6 marks, so make sure you link it properly. So let's start with gamma. What are they used for? So we're looking for a use and a harmful effect. So gamma is used to sterilize surgical equipment. However, it can cause cancer. So we've done both bits of the question. Moving on to UV. UV is used in tanning beds, so to make your skin brown. And as such, it can obviously not just cause your skin to become brown, but if you use them inappropriately, it can give you skin cancer. Next up, infrared. It doesn't matter which ones you use, by the way, these are my favourites. So infrared is used in remote controls. so it's a type of communication, but it also is used in cookers because remember infrared is just all about heating, so it can actually cause burns. (7a). The diagram shows a coin being dropped from height. The graph shows how the velocity of the coin changes until it hits the ground. State the equation linking acceleration, change in velocity and time. And I'm going to write this out in full. So acceleration equals change in velocity over time. The coin hits the ground in a time of 0.62 seconds with a velocity of 6.1 meters per second. Calculate the acceleration of the coin as it falls and give the unit. Got our equation above, which is acceleration equals change in velocity over time. So we're after acceleration. Now our change in velocity, we know that it hits the ground at 6.1 meters per second, and by the time it hits the ground it will be travelling with no velocity. So that's why our change in velocity is just 6.1. Our time is 0.62 seconds as given in the question. When you pop that into your calculator, you'll get an acceleration which is 9.8. Don't forget your units of acceleration, which is meters per second squared. And look, that's a sensible answer. Remember, you're supposed to know that objects accelerate at 9.8 meters per second when they're falling. State the feature on the graph that shows this acceleration. Well, you have a velocity time graph, which means that acceleration is given by the graph's gradient. Calculate the height from which the coin was dropped and use the graph to help you with your calculation. Right, there's the clue. It's a velocity time graph, so our height or distance travelled, remember they're the same thing, is the area under the graph. So we're looking for this area here. Now it's a triangle, which is why we need to have a half in our calculation. Let's look at this measurement along here. That's 0.62. Let's have a look along here. That's 6.1. If you read down the y-axis, that will tell you it's 6.1. Pop that into your calculator and you'll get an answer which is 1.89 meters. B. A ball is dropped from a very large height. The graph shows how the velocity of the ball changes until just before it hits the ground. Explain why the velocity of the ball changes in this way. Refer to ideas about forces in your answer. So the key here is that it's dropped from a very large height and we need to refer to forces, and it's worth 5 marks. So don't panic. What this is it's a poorly disguised terminal velocity question. So again, in my guide, you just want to learn a terminal velocity answer off by heart in order to get these 5 marks. So you want to say which direction all the forces are acting in. So you want to say weight acts downwards, drag or air resistance acts upwards, the ball accelerates, and drag increases. Eventually, drag equals weight, and there is no further acceleration, and the ball travels at constant velocity or constant speed. And you can see that here where the graph levels out. That's where terminal velocity has been reached. And that is done. 8. More electricity. The diagram shows an incomplete series circuit. Draw a thermistor to complete the circuit. We know, remember, that this looks like a hockey stick, so we're going to draw a regular resistor because it is a resistor, but it's a temperature dependent one, and there's your hockey stick. Add a voltmeter to the circuit to measure the voltage across the lamp, so it needs to go across the lamp. It's a voltmeter, so it has to go in parallel, which is why I'm adding it here. The voltmeter measures a voltage of 5.6 volts. The ammeter measures a current of 790 mA. State the equation linking current, voltage and resistance. So here's my formula triangle, VIR. So voltage is current times resistance. calculate the resistance of the lamp. So we need this version of the formula triangle, V over I. We've been told that the voltage is 5.6. We need to convert that 790 milliamps into amps, and we do that by dividing by 1,000 to get 0.79. And then once you pop that into your calculator, you'll get a resistance value of 7.1 ohms. The completed circuit is moved from a cold room to a hot room. Explain how this would affect the brightness of the lamp. So we're increasing the temperature, and we know we have a thermistor. So how does increased temperature affect the thermistor? So increasing, and you must just learn that increasing the temperature decreases the resistance of the thermistor. After all, it is a temperature dependent resistor. And as such, because our resistance has decreased, it means that the current will increase. So the lamp gets brighter. State how the current in the circuit would change if another lamp is added in series with the first lamp. Now remember your circuit rules. In a series circuit, the voltage is the same everywhere. So despite the fact they've added another lamp, you're going to just say that the current remains the same. Nine. This question is about magnetic fields. Which diagram shows the correct magnetic field pattern between the north poles of two bar magnets? So remember that these are going to be repelling. You need to have a look at your magnetic field pattern diagrams in order to actually know which is the correct answer. We know it's definitely not A or B, but it is worth looking at those diagrams so that you know that D is the answer. The diagram shows part of a magnetic field. Two magnetic field lines have already been drawn. Draw more magnetic field lines on the diagram to show a uniform magnetic field. So the fact it's uniform means that these lines need to be parallel and they need to be evenly spaced. I think that's enough. Describe how you would change your diagram to show a stronger magnetic field, and really you would just draw the lines closer together. So draw magnetic field lines. Closer together. 10. I'm not going to be able to pronounce this properly. Americium-241 is a radioactive isotope used in smoke detectors. It has the symbol 241 AM95. How many protons are in an americium, can't say it, 241 nucleus? So remember the top number is the mass number, bottom number is the atomic number, which is also the same as the proton number, which is why we can just say that it is 95. A. How many neutrons are in americium-241 nucleus? So to work out the number of neutrons, you need to do mass number, take proton number. So that's 241, take 95 to give you a value of 146, which is B. How many electrons are in a neutral, and it's neutral, americium-241 atom? So because it's neutral, it means that the electron number is the same as the proton number, which is why A is the answer here. When americium-241 decays, it emits alpha particles to form neptunium-237. Np is the symbol for neptunium. Complete the nuclear equation for the decay of americium-241. So alpha particles, remember these are made of 2 protons and 2 neutrons. So if you lose 2 protons, then the atomic number will decrease by 2. So that will become 93. And we're going to put a 2 there to represent those 2 protons. Now 2 protons and 2 neutrons, each of those particles has a mass of 1. So if you lose 4 of them, you'll lose 4 off of the mass number, which we have done. We've seen that it goes from 241 to 237, but that's why we need to put a 4 here. After the decay, the neptunium-237 nucleus emits gamma radiation. State what happens to the number of protons and neutrons in a nucleus as a result of gamma emission. They're trying to trick you out here. Remember that gamma is an electromagnetic wave, and therefore the number of protons and neutrons is unchanged. That is illegible. D. The diagram shows a cross-section through a smoke alarm. In normal operation, the count rate measured by the counter is 100 counts per second. If the count rate falls below 80 counts per second, the alarm sounds. Explain how the rising smoke causes the alarm to sound. So remember how smoke alarms work. So what happens is that there's a source of alpha and it's zapped out across the smoke alarm and it causes ionization of the air particles, making a small current which is detected by the smoke alarm. Now obviously when there's smoke there, because alpha is so unpenetrating, it means that that current is no longer produced and therefore the current isn't received by the detector. So we need to say that smoke absorbs the alpha particles meaning that fewer reach the detector. Americium-241 has a half-life of 430 years. Describe what is meant by the term half-life. Another definition you need to learn off by heart. It's the time taken for half the radioactive nuclei to decay. Americium-242 has a half-life of 16 hours and is a beta emitter. Explain why Americium-242 is not suitable for use in the smoke detector. I already said that the whole point of the alpha relies on the fact that it's not penetrating. So remember the difference with beta is that beta is too penetrating and therefore would not be absorbed by the smoke. The final, less obvious point would be that the smoke alarm would need replacing frequently. This question is about how light travels in water. Diagram 1 shows a ray of light from a torch submerged in a swimming pool. The ray of light does not pass through the water surface. State the name of this process. So yeah, the crucial thing here is that it doesn't pass through the water surface. It's reflected straight back at the water, and we know that this is total internal reflection. And you can actually get away by just writing TIR. Draw the normal on diagram 1 where the ray of light meets the water surface. Don't forget to read these questions, by the way. A lot of my tutees always seem to not see them. Make sure you answer every single question. So that's the line drawn at 90 degrees. Measure the angle of incidence. So it has to be the one coming from the torch and it sits between the ray and the normal. So there's that angle of incidence. So if you had a protractor, make sure you have one, you would measure it and that would come out at 70 degrees. State the angle of reflection. Well, the law of reflection states that the angle of incidence and the angle of reflection is the same. The torch is moved and the ray of light now passes through the water surface. Draw a line on diagram 2 to continue the path of the ray of light. So we need another normal. It's leaving and it's moving into a less optically dense environment, which is why and let me just remember this, so it bends towards the normal as it enters a glass block, it bends away as it enters the air, which is what it's doing here. So we're going to bend away. So here. State the name of this process. So when you see the light ray change direction like this, we call that refraction. State the equation linking critical angle and refractive index. Again, learn this. Do not lose marks by not being bothered to learn the correct equations. The refractive index of water is 1.33. Calculate the critical angle for the boundary between water and air. Give your answer to 3 sig fig. Don't forget that. So sine C equals 1 over n. Therefore, sine C equals 1 divided by 1.33. Pop 1 divided by 1.33 into your calculator and then click on the inverse sine function on your calculator to get an answer which, once you've rounded it to 3 sig fig, is 48.8 degrees. The torch is moved again so that the ray of light now meets the water surface at an angle of incidence of 52 degrees. Explain what happens to this ray of light. Well, our angle of incidence is now greater than the critical angle, which means that total internal reflection will occur. The diagram shows the basic details of a steam engine used in a steam train. Coal is burned in the firebox to heat up water in the boiler. Coal is a non-renewable fuel. Give an example of another non-renewable fuel. So these are fuels which will run out. So you could say oil or natural gas or petrol, diesel, anything sensible. This is how the steam engine works. Hot air from the firebox passes through a pipe to the chimney. Water is heated as the pipe passes through the boiler. The water boils to form steam. The steam is trapped by the closed inlet valve and continues to be heated. Explain why the pressure of the steam increases as its temperature increases. Well, that was a lot of information to read, but not very much because the question's just about collision theory. So remember, as temperature increases, particles gain kinetic energy. This means that they collide with the wall more frequently. I always laugh at these questions because they come up all the time, and that's why I put them in my revision guide, and they're always hidden to do with steam engines or foam cans or whipped cream cans, but they're always the same. So they collide with the wall more frequently, creating a larger force. And then crucially, the last thing you want to do is mention the appropriate equation, which is FAP. So pressure equals force over area, which is why that is appropriate to write. When the inlet valve is open, the steam moves into the cylinder. The steam exerts a force on the piston in the cylinder. State the equation linking pressure, force and area. And now I'm getting another mark for saying the same thing. So pressure equals force over area. The steam has a pressure of 1.45 MPa. The piston has an area of 0.0243 meters squared. Calculate the force exerted on the piston. So that's the version of the equation we need. We know the area is 0.0243. Let's make sure we do an appropriate conversion here. So we need to times it by 1,000,000. And the easiest way to write that is in standard form. And then when you've done that, you get a value which is 3.52 times 10 to the 4, which you can leave or you can write it out as an ordinary number. The force pushes the piston on so that the wheels turn and the train moves. This process transfers chemical energy from the coal into useful kinetic energy. State a type of energy that is wasted in this process, and it's always worth writing the sound or thermal energy here. The Sankey diagram shows the energy transfers in this process. Using the diagram, calculate the efficiency of the steam train. Oh, this is an interesting question. So efficiency is given by the equation useful energy out over total energy in times by 100. And they haven't given us any numbers, but they have told us that it's drawn to scale. So you can use your ruler here to measure various distances. So after useful energy out, which is this bit here, so use your ruler, you'll find that that is 9 millimeters. Looking at our equation, we need total energy in, which is here. Using your ruler, that will tell you it's 62 millimeters. So 9 over 62 times by 100 gives you a value of 14.5%. Cool, so that paper is done. Really hope you found it helpful. Please like it, subscribe. I really can't explain how difficult it is to make these videos. My voice is almost gone from talking through. So yeah, it is great if you show some love for the videos. I'll be back soon, guys. Take care. Bye.